Hello, this presentation is going to provide an overview of probability and the addition rule. So first, let's consider the notion of mutually exclusive events. And those are events that cannot occur at the same time. Okay, so you can't flip a head and a tail at the same time when you flip a coin, for instance. But some events can happen at the same time. If we draw two cards from a deck, it is possible that we'd get a diamond and a spade at the same time. So those are not mutually exclusive. For example, we might roll die, and the first event would be rolling a number that's less than 3. That would be event A, so that would be a 1 or a 2. Event B would be to roll a 4 on a die. Now those things are completely different, right? They don't have any overlap whatsoever. So they are considered mutually exclusive events. The next example is pulling jacks from a deck of cards for the first event. And then event B is selecting a heart. And these would be mutually exclusive if there was no jack of hearts. But jack of hearts is both a jack and a heart. So that is overlapping. These are not mutually exclusive events. And that brings us to the addition rule. And according to the addition rule, the probability that event A or B will occur is given by this formula here. Probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. So if we're talking about mutually exclusive events, that rules out this part of the equation, which is the probability of A and B. The probability of A and B is impossible with mutually exclusive events by definition. So that leaves us with the first part of the equation there, which is simply PA plus PB. So for example, you roll a die, and you want to find the probability that you roll a number less than 3 or a 4. The events are mutually exclusive. The probability of rolling a number less than a 3 or rolling a 4, recall from the previous slide here, this is our image, those are mutually exclusive. So probability of getting less than a 3 is getting a 1 or a 2. There are only 6 possibilities, so that's 2 out of 6. In the second event, the probability of getting a 4 is simply 1 out of 6. And according to the addition rule, we can just add those together. So that will give us the probability of 3 over 6, or 0.5. And if we go back to our Jack of Hearts example, represented by this image, remember these are not mutually exclusive events, that the math for that one is the probability of getting a Jack plus the probability of getting a heart minus the probability of getting the Jack of Hearts. And that is the overlapping segment where both events can happen simultaneously. So the probability of getting the Jack is 4 out of 52. Remember, these are independent trials, so we're putting the Jack back in the deck for the second event. So we've got 52 cards still. That's 13 out of 52 is the odds of getting a heart. And the odds of getting the Jack of Hearts is simply 1 out of 52. So if we take that and sum it together, we get 16 out of 52, or 0.308. And we apply the addition rule to one more example here of 100 college students who were surveyed and asked how many hours they spent studying, extending a previous example. Results are shown in this table, and we want to find the probability that a student will spend between 5 and 10 hours, or more than 10 hours, studying. So those are two possible outcomes, right? And we're talking about all students in this case, so that brings us down to the total row, rather than looking at only males or females, for instance. So the events, they are mutually exclusive. 5 to 10 is mutually exclusive of more than 10. Because of that, we don't have to subtract out the probability of both happening, because they can't both happen. You either study 5 to 10 or you study more than 10. You can't do both. So we just simply add those together. 46 is the number of students who claim to study 5 to 10 hours. The total is 100 students. That's 46 out of 100. And then those studying more than 10 hours is 30, so that's 30 out of 100. So just simply add those together, and you get 0.76.